heat transfer coefficient as 500 watt per meter square Kelvin. So it is asking that to find the Biot number and Fourier number 8 minutes after the initiation of the flow. So we have to in first case we have to find this Biot number and Fourier number. So let's find that. So before that, do you think that we need anything else to solve this problem? Of course, material properties. So properties of, let me give you the properties for this problem. Properties are generally function of temperatures for solids, and for liquids and gases both function of pressure and temperature. But for simplicity of the analysis, we are taking this properties at mean temperature, and some mean temperature which is nothing but the average of these two temperatures. Minus 20 plus 60 divided by 2. Divided by 2, 20 degrees Celsius. So properties are given at this temperature. All right. For the solid, rho, we need specific heat, we need thermal conductivity, and thermal diffusivity. Thermal diffusivity, which is nothing but K by rho Cp. Alright, which is 18.8 times 10 power minus 6 meters square per second. 7832 kg per meter cube. Specific heat at 434 joule per kg Kelvin. Thermal conductivity at 63.9 watt per meter Kelvin. So now we can find the Biot number. So by using H, so first of all we have to simplify this analysis, right? That which geometry we should use, right? Since we can see here that the thickness of the pipe is very, very small as compared to the diameter, we can think the thickness of the pipe as a plane wall, right? We can consider we can consider this area as a plane wall, right? Because thickness is very, very small and we are considering only one dimensional heat conduction. So assuming it to be like that, so it will look like this. If we see the close-up look, it is having convection on this surface and insulated from this surface. So it is, so plane wall case is very valid here. H times T infinity. This is x equal to 0 plane, and this is x equal to L plane, right? And this is steel, okay, because of oil. So let's find the Biot number. It is nothing but HL by K. L is nothing but the thickness, 40. H is 500 times L is 40 mm. We have to convert that into millimeter, and thermal conductivity is 63.9. So Biot number you will get as 0.313, which is greater than 0.1. It means that lumped capacity method is not valid here. Similarly, we can find the Fourier number. Fourier number is a dimensionless time, and for dimensionless time we will need the time absolute time, and they have provided that for 8 minutes you have to find this. L is 40 times 10 power minus 3. Alpha is thermal diffusivity 18.8 times 10 power minus 6 times 8 minutes means 8 into 60 seconds. The Fourier number will come out to be 5.64, which is greater than 0.2, which means that we can use the Hausler charts for further analysis. Okay, so the first case is done. Now we want to find that at t is equal to 8 minutes, what is the temperature of the exterior pipe surface covered by the insulation. It means this surface, we have to find the temperature. The temperature profile will look like this, and we can think is it is of a 2L thickness pipe plate, because it is insulated from air, so the slope will be 0 at this. So this information also now we use first. We have to find the temperature of this center plane. So for this finding the temperature of center plane, we will be needing the reciprocal of Biot number, as we can go and see this. For finding the center plane temperature, we will be needing the reciprocal of Biot number and the Fourier number. Fourier number we have already calculated. So the center plane temperature, which is we are calling as the, let's say, surface temperature, Ts minus T infinity upon Ti initial temperature minus T infinity is a function of 1 by Biot number and Fourier number. If we found this from the chart, it will come out to be 0.214, and Ts we can find by input all the variables. T infinity we know. T infinity is the some ambient temperature, which is nothing but 60 degrees Celsius. So put that, okay, 60 plus Ti is minus 20 plus minus T infinity is 60 times 0.214. So surface temperature is come out to be 42.9 degrees Celsius. So initially the body is at minus 20 degrees Celsius. With the initiation of the flow, the surface temperature on the outside reaches a 42.9 degrees Celsius. Alright. It is